Good day everyone, I'm Sean Patrick Ibarra, the leader of Group 2. Our topic for today is Chapter 3, which is MANET or Mobile Ad Hoc Network. So guys, what is Mobile Ad Hoc Network or MANET? It refers to network formed by group of mobile devices or nodes that can communicate with each other without relying on centralized administrator. In manets, devices establish direct communication, links with nearby nodes, allowing for dynamic and self-configuration networks. These networks are particularly useful in situations where traditional infrastructure-based networks are unavailable or impractical, such as in emergency response scenarios or military operations. Manets rely on protocols that enable efficient routing and communication among nodes, adapting to changes in network topology and node mobility. These are the different protocols can be used for communication of these nodes with each other. And they are: number 1, Destination Sequence Distance Vector or DSDV. Number 2 is Dynamic Source Routing or DSR. Number 3, Temporarily Ordered Routing Algorithm or TORA. And number 4, Ad Hoc On-Demand Distance Vector or AODV. Number 1, Destination Sequence Distance Vector or DSDV. This protocol maintains a routing table at each node which contains the next hop for each destination along with the sequence number to avoid loops in the network. Imagine guys, a group of mobile devices forming an ad hoc network in a disaster area where traditional communication infrastructure is damaged. DSDV can be used to establish communication between these devices by maintaining routing tables at each device, ensuring reliable communication by using sequence number to prevent loops. Number 2, Dynamic Source Routing or DSR. DSR is a reactive routing protocol where nodes maintain routes to destinations by learning them on demand. When a node needs to send a packet of destination, it includes the full route in the packet header. For example, in a military operation where troops are deployed in remote area, DSR can be employed to establish communication between soldiers equipped with portable devices. When soldier needs to send a message to a specific location, DSR allows them to dynamically discover and utilize routes by including routing information in the packet header. Number 3, Temporally Ordered Routing Algorithm or TORA is a proactive routing protocol that constructs a directed acyclic graph or DAG routed at the destination. It uses local route updates to maintain multiple routes to each destination. For example, consider a team of drones performing search and rescue operation in a disaster-stricken area. TORA can be utilized to establish efficient communication among these drones by maintaining a directed acyclic graph routed at the base station. This allows the drones to maintain multiple routes to the base station, adapting to changing network condition in real time. And the last one is Ad Hoc On-Demand Distance Vector or AODV. It's also a reactive routing protocol where nodes maintain routes to destinations only when needed. It uses route request and route reply message to discover and maintain routes in the network dynamically. For example, in a scenario where a group of vehicles forms an ad hoc network for inter-vehicle communication on a highway, AODV can be used. When a vehicle needs to transmit data to another vehicle, AODV allows it to dynamically discover and maintain routes by sending route request messages and receiving route replies messages from neighboring vehicles, ensuring efficient communication without the need for pre-established routes. Mobile ad hoc network, also called as a wireless ad hoc network or ad hoc wireless network, that usually has routable networking environment on top of a link layer ad hoc network. Manets consist of peer-to-peer, self-performing, self-healing networks manets circa 2000 to 2015 typically communicate at radio frequency at 30 MHz and 5 GHz.
Imagine a network without cell phone tower. That's a mobile ad hoc network, which is MANET. In a MANET, devices like laptops, phones, or sensors connect directly with each other wirelessly, instead of needing a central hub. These self-sufficient networks can even talk to each other, forming larger networks. Even cooler, MANETs can adjust on the fly as devices move around or enter or leave the network. This makes them useful in situations where traditional towers are impractical. Wireless localization in mobile ad hoc networks. In a regular network, cell phone towers keep track of where your phone is. But what about networks without towers? This is where wireless localization comes in. In mobile ad hoc networks, MANETs, since devices directly communicate with each other, we need special techniques to figure out where each device is physically located within the network. This is crucial for the network to function properly.
So here are the challenges such as dynamic network topology. These frequent changes in node positions due to mobility necessitate continuous location updates. The next one is resource constraints. This one has limited battery power and processing capabilities, often restrict complex localization algorithms. Next one is scalability. Techniques need to efficiently manage varying numbers of nodes in the network 10. And here are the benefits of this, such as location-based services that enables applications like navigation, asset tracking, and resource management based on node location. Next one is emergency response. This one locates first responders and victims.
Goals of location management. Accurate location information. The primary goal of location management is to maintain accurate and up-to-date location information for each node in the network. Minimal overhead. Location management system should be designed to minimize the communication and processing overhead required to maintain location information. Scalability. As mentioned previously, location management systems need to be scalable to accommodate a varying number of nodes. Privacy preservation. Some location management systems may collect sensitive information about the user location. It is important to design systems that protect user privacy.
It also has GPS for localization in manets, such as GPS Global Positioning System serve as a popular option for outdoor localization within manets. The advantages of this, such as high accuracy, that offers accurate location information in open environments with clear sky visibility. Next is standardized technology, widely available and well-established technology with readily available receivers. And here are the limitations, such as outdoor dependence. This one is unreliable indoors or in areas with limited sky visibility due to signal blockage. The last one is energy consumption. This one is continuous GPS usage can significantly drain the battery life. We also have the challenges such as dynamic topology. This one is frequent changes in node positions due to mobility to make it difficult to maintain accurate location information. Next one is limited resources. Nodes in manets often have limited battery, power, and computational capabilities, making complex localization algorithms impractical. Third is scalability. This one is localization techniques need to be efficient and scalable to handle a varying number of nodes in the network. And some of the applications are resource management, optimizing resource allocation based on node location. Next one is location-based services, providing location-aware applications like navigation and asset tracking. Next is wireless localization using GPS technology in mobile ad hoc networks in manets. And the last one is wireless localization in manets, averages various wireless communication technologies including GPS to determine the physical location of individual nodes within the network.
Location management techniques. Proactive location management. This approach anticipates node movement. Node periodically broadcasts their location updates to other nodes within a specific range. This ensures everyone has relatively fresh location information, enabling efficient route discovery. Advantages. Fast location lookup as recent updates are readily available. Limitations generate significant control overhead due to frequent updates, consuming battery power and bandwidth, not suitable for highly dynamic networks with rapid movement. Reactive location management. This approach only fetches location information when needed. When a node needs to send data, it initiates a location search for the recipient. This search involves flooding the network with location requests until the target node is found. Advantages. Saves bandwidth and battery life compared to proactive updates. Limitations. Can cause delay in communication while searching for the target node. The flooding mechanism can overload the network in large manets. Location-aided routing. This technique integrates location information into the routing protocol itself. During route discovery, nodes not only exchange reachability informations but also their location details. This allows the routing protocol to choose paths based on physical proximity, potentially leading to more efficient routing. Advantages. Combines location management with routing, reducing overhead compared to the separate mechanisms. Limitations. Requires modifying existing routing protocols to incorporate location information. May not always guarantee the optimal path if the other factors like congestions are not considered. Hierarchical location management. This approach divides the network into geographical zones with designated location servers. Managing each zone, nodes register their location with the server in their current zone. Location lookups involve querying the relevant server, reducing network flooding compared to reactive techniques. Advantages: scalable for large manets, reduces control overhead compared to fully proactive updates. Limitations: introduces additional complexity with server management and maintaining zone hierarchy. Relies on the stability of location servers, which might be mobile nodes themselves. Ad hoc mobile networks offer several advantages. Flexibility. Rapid deployment manets don't require pre-existing infrastructures like base stations or cables. Devices can form a network on the fly, making them ideal for temporary situations like conferences, disaster response, or remote sensor networks. Adaptability. Since there's no central control, the network can adapt to changing environments. New devices can easily join and the network can reconfigure itself if nodes move around. Scalability. Dynamic network size manets can seamlessly accommodate a varying number of devices. They can grow as more devices join the network and shrink as devices leave without affecting overall functionality. This is particularly useful for applications with fluctuating device participation. Resilience. Decentralized structure. The lack of central point of failure make manets inherently robust. If one node malfunctions or becomes unreachable, other nodes can take over its routing duties. This ensures communication can continue with other partial network disruptions. Self-healing capabilities. Manets can automatically detect and adapt to change in the network. If a node goes down, remaining nodes can discover new routes to maintain connectivity. While manets offer flexibility, scalability, and resilience, They also come with certain disadvantages and limitations. Instability. Unreliable connections. Due to constant node movement, signal strength can fluctuate, leading to frequent link breaks and unreliable connections. This can be disruptive for applications requiring real-time data transfer. Limited scalability. Complexity in large network managing routing and maintaining network connectivity becomes more challenging as the number of devices in a manet increases. The overhead of route discovery and updates can significantly impact performance. Security challenges. Open network access. Since there's no central control for users' authentication, unauthorized device can potentially gain access to the network. This makes manets vulnerable to eavesdropping and malicious disadvantages shows the need for careful design consideration when deploying manets. Techniques like improved routing protocols, power-saving mechanisms, and robust security solutions are being developed to address this limitation and enhance the overall effectiveness of manets.
Types of manets from our list. Mobile ad hoc networks manets. This is the most general term for this type of networks. Manets are dynamic wireless networks that don't rely on a fixed infrastructure like a cell phone tower or base station. Instead, individual mobile devices communicate directly with each other. Number 2. Vehicular ad hoc networks, which is VANETs. These are networks created by vehicles to share information with each other. This information can include traffic conditions, accidents, and other road events. Bonnets are becoming increasingly important for the development of autonomous vehicles. Number 3, smartphone ad hoc networks, SPANs. These are networks formed by smartphones to share data or collaborate on tasks. For example, a group of students working on a project together could create a SPAN to share files and communicate with each other. Here are the references.